March 23, 1943. Major Klaus Weber pushed his Messerschmitt Bf 109 Gustav into a steep dive over the Rhine Valley, watching his airspeed indicator climb past 400 miles per hour. Behind him, two American P-38 Lightnings had been pursuing him for the past 10 minutes, their distinctive twin-boom silhouettes growing smaller in his mirrors as he executed the maneuver that had saved countless Luftwaffe pilots. Weber smiled grimly as he pulled out of the dive at 5,000 feet, knowing the Americans would be unable to follow. The technique had become standard doctrine among German fighter pilots. When faced with the Lightning's superior firepower and range, simply dive away. The Americans, with their sleek twin-engine fighters, would be trapped by their own aircraft's deadly limitation. The problem plaguing the P-38 Lightning was compressibility, a phenomenon that occurred when the aircraft approached transonic speeds in steep dives. As the Lightning dove, shock waves formed over its wings, causing the aircraft to lose control effectiveness and lock into an unrecoverable dive. German intelligence had identified this weakness early in 1943, and Luftwaffe pilots exploited it mercilessly. Lieutenant Robert "Lucky" Morrison, piloting one of the pursuing Lightnings, felt his aircraft begin to vibrate violently as he followed Weber's dive. His control surfaces became sluggish, then unresponsive. The familiar terror of compressibility gripped him as his P-38 locked into a death dive, the ground rushing up with terrifying speed. Only by cutting his engines and deploying full flaps could Morrison recover, by which time Weber had vanished into the German countryside. This scenario repeated itself countless times across European skies. German fighter pilots not wishing to fight would perform the first half of a split S and continue into steep dives because they knew the Lightnings would be unable to pursue them safely. The tactical advantage shifted dramatically in favor of the Luftwaffe, despite the Lightning's superior specifications on paper. Colonel Harold Hal Roux, commanding the 55th Fighter Group based in England, watched his pilots return from missions with mounting frustration. His squadron had lost 6 aircraft in 2 weeks, not to enemy fire, but to compressibility-induced crashes. The Lightning, which had shown such promise in the Pacific theater, was proving vulnerable in European combat conditions. German pilots grew increasingly confident in their escape tactics. Hauptmann Friedrich Walkner of Jagdgeschwader 53 regularly briefed his pilots on the American weakness. When the fork-tailed devils come for you, dive deep and fast. They cannot follow without killing themselves. The Americans had given the Germans an unexpected advantage, and the Luftwaffe intended to exploit it fully. November 15, 1943. Kelly Johnson, Lockheed's Chief designer, stood in the wind tunnel facility at the California Institute of Technology, watching smoke streams flow over a scale model P-38. The visualization clearly showed the formation of shock waves that caused the dreaded compressibility effect. For months, Johnson's team had been racing against time to solve the problem that was costing American lives over Europe. The solution lay in dive recovery flaps, small aerodynamic surfaces that could be deployed to disrupt the shock wave formation and restore control authority during high-speed dives. Johnson had identified the fix by late 1943, but implementing it across the fleet would require extensive modifications to existing aircraft and integration into new production lines. Meanwhile, in Germany, Luftwaffe test pilot Major Hermann Weber was conducting combat evaluations of captured P-38 aircraft at Rechlin Airfield. Weber had confirmed the Americans' vulnerability through systematic testing, pushing the Lightning to its limits in controlled dives. His report to the Reich Air Ministry was unambiguous. The enemy aircraft becomes uncontrollable beyond 450 miles per hour in diving flight. This weakness can be consistently exploited in combat. Back in California, Johnson's engineering team worked around the clock to develop dive flap kits that could be retrofitted to existing P-38s in the field. By late 1943, Lockheed had dive flap kits ready for field modifications. These would allow P-38s in various theaters to handle compressibility better. The solution was elegant. Electrically operated flaps mounted beneath each wing that would automatically deploy at high speeds, breaking up the shock wave formation. Captain William Levinson, a test pilot at Muroc Army Airfield, conducted the first trials of the dive flap system in December 1943. Strapped into a modified P-38J model, Levinson pushed the aircraft into increasingly steep dives, monitoring the new system's performance. At 460 miles per hour, well beyond the previous compressibility threshold, the dive flaps deployed automatically and the Lightning remained controllable. The test results were promising, but logistical challenges loomed large. Shipping the modification kits to combat theaters required careful coordination with Allied transportation networks. Each kit weighed over 200 pounds and required specialized installation tools and trained technicians. The modification process took approximately 40 hours per aircraft, removing fighters from combat operations during critical periods. German intelligence remained unaware of the American solution in development. Oberst Hans Kogler, analyzing combat reports from the Western Front, noted with satisfaction that Lightning losses continued to mount through the winter of 1943. His assessment to Luftwaffe High Command concluded that the American twin-engine fighter posed minimal threat to experienced German pilots who understood its limitations. March 8, 1944. Captain James Mitchell guided his C-54 Skymaster transport through heavy cloud cover over the English Channel, unaware that his cargo would become one of the war's most tragic friendly fire incidents. In his hold sat 200 dive flap modification kits destined for P-38 squadrons across England, enough to solve the compressibility problem that had plagued American fighter operations for months. Flight Lieutenant David Pemberton of the Royal Air Force was conducting a routine patrol in his Supermarine Spitfire when he spotted the four-engine transport emerging from the clouds. The aircraft's silhouette confused him in the poor visibility conditions. Without proper identification friend or foe equipment functioning, and facing standing orders to intercept unidentified aircraft, Pemberton made a fatal decision. Unidentified aircraft, "You are in restricted airspace," Pemberton radioed, but received no response due to radio frequency mismatch. The C-54 continued on its course toward an RAF base in Suffolk. Mitchell, unaware of the approaching danger. Pemberton, believing he was engaging a German transport, opened fire with his 20mm cannons. The C-54 erupted in flames and plummeted into the channel, taking Mitchell, his crew of 4, and the precious cargo to the bottom. In March 1944, an RAF fighter downed a C-54 carrying 200 kits to England, mistaking it for an enemy craft. The loss represented months of engineering work and production delays that would cost American pilots dearly in the coming months. Colonel Thomas Hubbard, operations officer for the 8th Air Force, received the devastating news at his headquarters in High Wycombe. The dive flap kits represented the difference between life and death for Lightning pilots facing experienced German opponents. Without them, P-38 squadrons would continue to suffer losses from compressibility-related crashes and enemy pilots who exploited this weakness. Meanwhile, Hauptmann Georg Steinhoff was leading his staffel of Focke-Wulf 190 A8s on an intercept mission near Hamburg when they encountered a formation of P-38s from the 364th Fighter Squadron. Steinhoff immediately ordered his pilots into a diving attack, knowing the Americans would be unable to pursue effectively. Lieutenant Charles "Chuck" Roberts, flying the lead Lightning, watched helplessly as the German fighters dove past his formation and escaped toward the deck. His aircraft shuddered as he attempted to follow, the familiar symptoms of compressibility beginning to manifest. Roberts was forced to abandon the pursuit, allowing Steinhoff's formation to escape unscathed. The pattern repeated itself across European skies throughout the spring of 1944. German pilots grew increasingly bold in their tactics, confident in their ability to escape American pursuit through high-speed dives. The sunken C-54 and its cargo represented more than material loss. It symbolized the continuation of American tactical disadvantage in European aerial combat. June 12, 1944. At the Lockheed plant in Burbank, California, production lines hummed with renewed urgency as workers installed dive flap systems on newly manufactured P-38 J-25 Lightning aircraft. By 1944, Johnson had identified and resolved the flaws in the Lightnings, airframe adding power-assisted ailerons and dive flaps that respectively improved its roll rate and corrected its tendency to lock into steep dives. The dive flap system represented a masterpiece of aeronautical engineering under wartime pressure. Each flap measured 18 inches by 36 inches and was positioned strategically beneath the wing's center section. When aircraft speed exceeded 400 miles per hour in a dive, an automatic system deployed the flaps to 8 degrees, disrupting the shock wave formation that caused compressibility. Major William Anderson, recently assigned as chief test pilot for the dive flap program, conducted extensive trials at Edwards Army Airfield. Anderson's methodical approach involved pushing modified P-38s well beyond their previous operational limits. In test after test, the dive flap system performed flawlessly, allowing Lightning pilots to maintain control at speeds that would have been fatal in earlier variants. The engineering solution required sophisticated manufacturing precision. Each dive flap operated through an electrically powered actuator system connected to the aircraft's pitot-static instruments. As airspeed increased beyond the critical threshold, pressure sensors triggered automatic deployment. Pilots could also manually deploy the flaps using cockpit controls, providing additional flexibility in combat situations. Across the Atlantic, German intelligence remained oblivious to the American breakthrough. Oberst Klaus Neumann, analyzing Allied aircraft capabilities for the Luftwaffe Technical Office, continued to assess the P-38 as vulnerable to diving attacks. His reports emphasized exploiting the compressibility weakness that German pilots had successfully used throughout 1943 and early 1944. Lieutenant Colonel Frank Everest, commanding the 4th Fighter Group at RAF Debden, received the first shipment of modified P-38 J-25 aircraft in July 1944. The bare metal finish of these new Lightnings gleamed in the English summer sun as ground crews conducted pre-flight inspections. Everest gathered his squadron commanders for a classified briefing on the new dive flap capabilities. "Gentlemen, the playing field is about to change," Everest announced to his pilots. "These new birds can follow Jerry straight down to the deck without losing control. The Krauts have been using our compressibility problem against us for over a year. Time to return the favor." The pilots listened intently, understanding that the tactical equation was about to shift dramatically in their favor. Flight Sergeant Tommy Williams, a veteran Lightning mechanic with over 2 years of experience on the type, marveled at the dive flap installation. The system represented a quantum leap in aeronautical engineering, addressing a problem that had cost dozens of American lives and countless missed opportunities against German fighters. August 27, 1944. Captain Richard "Dick" Bong, America's leading ace, gripped the controls of his modified P-38L Lightning as he dove after a formation of German Messerschmitt Bf 109G models over Bavaria. For the first time in months, an American pilot could pursue diving German fighters without fear of compressibility-induced loss of control. The dive flaps deployed automatically as Bong's airspeed climbed past 450 miles per hour. Instead of the violent vibrations and control lockup that had plagued earlier Lightning variants, his aircraft remained stable and responsive. The German pilots below, executing their standard escape maneuver, were about to receive a deadly surprise. Lieutenant Hans Miller, flying the lead Messerschmitt, glanced back confidently as he led his swarm into a steep dive toward the Bavarian countryside. The tactic had worked countless times before. American P-38s simply could not maintain pursuit in high-speed dives. Muller's confidence turned to horror as he saw Bong's Lightning following closely, its guns already beginning to twinkle with muzzle flashes. The engagement ended quickly and decisively. Bong's first burst caught Miller's Messerschmitt in the engine compartment, sending the German fighter spinning out of control. The other German pilots, witnessing their leader's destruction, scattered in panic. For the first time, their tried and tested escape maneuver had failed catastrophically. Word of the new Lightning capabilities spread rapidly through German fighter units. Hauptmann Walter Kropinski, a veteran pilot with over 100 victories, received disturbing intelligence reports from surviving pilots. "The Americans can now follow us in dives," reported Obergefreiter Stefan Weber after a harrowing encounter with modified P-38s near Stuttgart. "Their fork-tailed devils no longer suffer from the control problems we have exploited." The psychological impact on German pilots was immediate and profound. The diving escape maneuver had provided psychological comfort as well as tactical advantage. Knowing they possessed a reliable means of escape from dangerous situations had allowed German pilots to engage American formations with confidence. That confidence was rapidly eroding as reports of successful American pursuits multiplied. Colonel Charles MacDonald, commanding the 475th Fighter Group, noted the dramatic change in combat dynamics during August operations. His squadron's kill-to-loss ratio improved dramatically as German pilots found themselves unable to break contact through diving attacks. "The Krauts are learning that their old tricks won't work anymore," MacDonald reported to 8th Air Force Headquarters. Major Klaus Weber, the same German pilot who had successfully escaped American pursuit in March 1943, found himself in a desperate fight for survival over the Rhine Valley. 2 P-38 Lightnings had pursued him through a diving attack that should have guaranteed escape. Instead, Weber watched in terror as the Americans maintained formation behind him, their guns preparing to deliver fatal judgment for months of successful evasion. October 13th, 1944. Generalmajor Adolf Galland, commander of German fighter forces, stood before a situation map at Luftwaffe headquarters in Berlin, studying disturbing reports from the Western Front. The red markers indicating fighter losses had multiplied dramatically since August, and intelligence reports painted a troubling picture of American tactical improvements. "The enemy has solved their diving problem," reported Oberst Johann Steinhoff during the morning briefing. "Our pilots can no longer rely on diving attacks to break contact with American twin-engine fighters. The P-38 has become significantly more dangerous." Galland studied the combat loss figures with growing concern, recognizing that a fundamental shift in aerial warfare dynamics was occurring. Galland immediately ordered tactical revisions throughout the Luftwaffe fighter arm. New directives emphasized avoiding prolonged engagement with Lightning formations, recommending hit-and-run attacks using superior climb performance of German single-engine fighters. The standard diving escape maneuver was quietly retired from official combat doctrine. Meanwhile, at Rechlin Test Center, Major Hermann Weber conducted urgent evaluations of captured P-38J model aircraft equipped with dive flaps. Weber's test flights confirmed German pilots' field reports. The Americans had indeed solved their compressibility problem. His technical report to the Reich Air Ministry recommended immediate development of countermeasures. The German response focused on exploiting remaining Lightning weaknesses. Intelligence analysis identified the P-38's poor roll rate and limited maneuverability at low speeds as potential tactical advantages. New combat techniques emphasized tight-turning engagements at reduced altitudes, where German fighters' superior agility might still provide advantage. Hauptmann Erich Hartmann, the war's leading ace with over 300 victories, adapted his combat techniques to address the new American capability. "We must avoid diving away from the twin-engine fighters," Hartmann briefed his pilots. "Instead, engage in climbing turns or low-altitude maneuvering where our aircraft maintain advantages." The psychological adjustment proved difficult for pilots accustomed to reliable escape options. Captain Chuck Yeager, flying a modified P-38L model, engaged a formation of Focke-Wulf 190D models over western Germany in late October. The German pilots attempted their traditional diving escape, only to find Yeager's Lightning matching their every maneuver. The engagement resulted in 3 confirmed kills and marked another example of the tactical revolution in progress. The ripple effects of the dive flap modification extended beyond immediate combat effectiveness. German fighter production priorities shifted toward aircraft with superior high-altitude performance, recognizing that low-altitude sanctuary no longer existed. The Messerschmitt Me 262 jet fighter program received increased emphasis as conventional fighters struggled against improved American capabilities. December 7, 1944. The sky over the Ardennes forest erupted in aerial combat as German fighters attempted to support the surprise offensive that would become known as the Battle of the Bulge. Major George Preddy, leading the 352nd Fighter Squadron, spotted a large formation of German aircraft and immediately ordered his P-38 Lightnings into attack position. The ensuing engagement demonstrated the complete tactical transformation that dive flaps had brought to Lightning operations. German pilots, attempting their traditional diving escapes, found themselves pursued relentlessly by American fighters that no longer suffered from compressibility limitations. The psychological advantage that had sustained German morale through months of difficult fighting evaporated in minutes of deadly combat. Oberleutnant Franz Stigler, a veteran pilot with 47 victories, led his swarm of Messerschmitt Bf 109K models in a desperate attempt to escape pursuing Lightnings. The Americans followed him through a diving attack that reached over 500 miles per hour speeds that would have guaranteed escape just 6 months earlier. Stigler's aircraft was hit repeatedly before he could reach cloud cover. The combat reports from December 19, 44 operations painted a stark picture of German fighter ineffectiveness. American P-38 squadrons achieved kill ratios exceeding 8-to-1 against German opposition, largely due to the elimination of compressibility-induced escape opportunities. German pilots found themselves trapped in prolonged engagements they could not break off successfully. Lieutenant Robert Johnson, flying wing position for Major Preddy, experienced the satisfaction of pursuing German fighters through previously impossible diving attacks. "It felt like we finally had our hands untied," Johnson reported after the mission. "The Krauts kept trying their old dive-and-run tactics, but we stayed right with them all the way down. The tactical revolution was complete." German intelligence efforts focused desperately on understanding American technical improvements. Captured Lightning aircraft were subjected to intensive examination at Rechlin and other test facilities. The dive flap system's elegant simplicity frustrated German engineers, who realized that retrofitting existing aircraft would be impossible given wartime production constraints. Major Klaus Weber, who had successfully evaded American pursuit through diving tactics since 1943, was finally shot down on December 20, 1944. His Messerschmitt was caught in a diving engagement with P-38 Lightnings that followed him relentlessly to low altitude. Weber survived the encounter but spent the remainder of the war as a prisoner, his successful evasion tactics rendered obsolete by American engineering innovation. The psychological impact on surviving German pilots proved as devastating as the tactical disadvantage. Pilot confidence, already strained by fuel shortages and overwhelming Allied numerical superiority, suffered another severe blow. The knowledge that their most reliable escape technique no longer provided safety created additional stress in an already desperate situation. February 28, 1945. The war in Europe was drawing to a close, and the statistics told the story of American technological triumph. P-38 Lightning squadrons equipped with dive flaps had achieved combat effectiveness levels that exceeded even the most optimistic predictions from engineering teams at Lockheed's Burbank facility. The numbers were staggering. Lightning losses to compressibility-related crashes had dropped to virtually zero after dive flap installation, while kill ratios against German fighters increased by over 300%. Late-war bare metal P-38J and L models incorporated these fixes, representing the culmination of American engineering innovation under wartime pressure. Colonel Francis Gabreski, reviewing combat statistics at 8th Air Force Headquarters, marveled at the transformation. The dive flaps didn't just solve a technical problem, he noted in his final report. They fundamentally changed the balance of power in European aerial combat. German pilots lost their psychological edge along with their tactical advantage. The engineering solution that Kelly Johnson's team had developed represented more than aeronautical innovation. It demonstrated American industrial capability to identify, solve, and implement solutions to complex technical challenges under combat conditions. The dive flap modification had been conceived, tested, and deployed across multiple theaters within 18 months, a remarkable achievement given wartime constraints. German post-war analysis revealed the devastating impact of American technical improvements. Generalmajor Adolf Galland, reflecting on the war's aerial campaigns, identified the Lightning dive flap modification as one of several critical turning points that sealed German defeat. When the Americans solved their diving problem, they eliminated our most reliable tactical advantage, Galland wrote in his memoirs. Lieutenant Charles Roberts, who had been forced to abandon pursuit of German fighters due to compressibility problems in March 1944, experienced the satisfaction of successful engagement in the war's final months. Flying a modified P-38L model, Roberts achieved 6 confirmed victories against German fighters who could no longer escape through diving maneuvers. The story of the P-38 dive flaps represented American problem-solving at its finest. Faced with a technical challenge that was costing pilots lives and tactical advantage, American engineers, test pilots, and manufacturing personnel had collaborated to develop and implement an elegant solution. The modification had turned a significant liability into a decisive advantage. As Allied forces advanced into Germany itself, the few remaining Luftwaffe pilots faced an impossible situation. Their aircraft were increasingly outnumbered, fuel supplies were critically short, and their most reliable combat tactic had been neutralized by American engineering innovation. The psychological impact proved as devastating as the tactical disadvantage, contributing to the collapse of German air resistance in the war's final months. The dive flap modification ultimately saved hundreds of American lives while contributing significantly to Allied air superiority over Europe. Germany had indeed never expected such a simple innovation to transform the deadly equation of aerial combat, turning their tactical advantage into devastating vulnerability.